Hi everyone, welcome back to my channel. Uh, Today we're going to talk about a very important topic, which is Sliver C2. This is actually very important because we've talked about Metasploit already. The purpose of Metasploit was like to get the initial access, to get access to the victim's machine, just the initial access. But once we get the initial access, there are something that we need to do. Like the second step, the next stage is actually called post-exploitation. We have to find a way how we can stay there without being detected. How our malware can stay there without being detected for as long as possible, and it has to also be able to persist even after restart or reboot, and also we need to move around to find other victims on the same network. Call it lateral movement, and also escalate our privilege to get higher permissions in order to be able to run more advanced tools like Mimikatz, in order to dump credentials, get more access to the system and networks. So in order to achieve all this, actually you need a tool like Sliver C2. Okay, so usually this is a very good tool. This is a modern open source tool. Like, it's an alternative to Cobalt Strike. If you know Cobalt Strike, also it's a command and control tool. It's an open source command and control tool framework developed by Bishop Fox for red team operation and adversary emulation. It's a modern alternative to frameworks like Cobalt Strike, Metasploit, and Empire. Empire is useful as well, but it's a little bit old. And Metasploit actually works with Sliver, so you can use Metasploit to get the initial access and use Sliver just to maintain access. Okay. After getting the initial access, Cobalt Strike is the best out of all of those tools actually. But this is a paid alternative, and it's very hard to find. So we have the key features that we need to focus on that Sliver C2 has is that it has multi-protocol support. Okay, like it supports MTLS, HTTPS, DNS, and WireGuard. Okay, basically MTLS is like TLS, but that can communicate in two ways, like two ways. We will talk about it later. But HTTPS, I think we know about HTTPS, just secure hypertext transfer protocol. It encrypts the traffic that goes to the network. DNS just translates, and this is used with VPNs. WireGuard, and it supports both different platforms. Sliver supports Windows, Linux, and Mac OS. It supports also multi-layer. Multiple operators can control sessions simultaneously. Okay, multiplayer, yeah. And it's implant flexibility. It has sessions, interactive, and beacons. There are two types actually that we will be dealing with: sessions and beacons. Basically, the difference is that beacons is asynchronous, and it takes time. Actually, sometimes you just give it a task or a command. Okay, it just waits in the queue. It has like the queue, and it executes. Like, there's an interval, specified time that it waits before calling back again, taking the task to do that. So session is immediate. You get results output immediately. That's the main difference. Beacon uses callback, and sessions just fast. But this is beacons are stealthier actually. They're difficult to detect, and sessions are noisy also. So we'll talk about the difference. And Sliver also has extensibility. That means armory system for third-party tools. Okay. Yeah, armory system. It has a system for third-party tools. You can download tools like PSExec. You know PSExec for lateral movement. You can download Sharphound, which is a data collector for Bloodhound, like for Active Directory. And you can download, like there are many tools you can actually download. Mimikatz as well. You can download it, make it execute it as part of the Sliver commands. Okay, we're using armory system. We'll talk about this as well in the details. And evasion, it's built-in obfuscation. Okay. Yeah, it supports also, Sliver supports evasion, so it obfuscates the malware. It has anti-forensic OPSEC features, and it's under active development, frequently updated, community driven. Yeah. So the architecture is that the operator console and Sliver server and listener implant on a target. So that's the idea. Like, yeah, the operator console. Usually there is a command Sliver, like dash server. Okay, to open for you the operator console, and then this is the Sliver server. Yeah, and then you can set up a listener. A listener you can set it up with, if you want to set it up with different protocols here. Like you can use MPLS if you want to use MPLS. If you want HTTPS, if you want DNS, that's up to you. You can set up a listener for this, to listen for this, and then you can generate the malware and implant on a target. We call it implant here. The implant is a payload deployed on a target system. Client or console interface for operators, server, central component managing implants and operators. So we'll be dealing mostly with server, and listeners, network service waiting for implant callbacks. Yeah. Actually, that's the purpose. Yeah, when we set up a listener using any protocol from this, it's just going to be waiting for a callback from the implant, which is implant is just a payload that's deployed on a target. You know, we used just like an example, like remember we used MSF Venom to create a payload and transfer it to the victim machine, and when it's executed, we received a reply on the listener. Like we used multi-handler listener in Metasploit, so it's a similar concept. So session versus beacons. The thing with this is that we have real-time connection sessions. It's persistent, always on communication. This is the characteristics of a session. And immediate execution. Commands execute instantly. Yeah, I told you right. In beacons, you have to wait for the next callback to execute it. Any command you waits for the next callback to execute it, while session commands just execute immediately. Okay, and higher network noise, continuous connections, and more detectable. This is more detectable. Okay, session is more detectable because it's actually you just type a command, it just executes immediately, right? So it's actually noisy and resource intensive, maintains constant connection. Okay, when to use, sessions are actually used only during the initial exploitation, okay, and rapid enumeration. Interactive tasks requiring immediate feedback. If you have a task that you need to get feedback fast, or short duration operation, testing, or lab environment when stealth is not critical. This is very important. You need to understand this because sessions are very noisy and can be detected easily by SOC teams or ADR or any tools. security tools inside the organization. And network pattern is like the implant. This is how it works. When we go to beacons, beacons is basically asynchronous mode. It runs on asynchronous mode. That means it has a periodic callbacks. This is a very important concept. It checks in at intervals. Example, every 60 seconds or some other number. Yeah, this is not a fixed. This is the default, but you can change this one actually. And every 60 seconds it's going to check by default. Checks the queued commands. Commands wait for the next callback to execute. Okay, you can type as many commands as you want. They're not going to be executed immediately. They're just going to wait there on the queues until the next callback. Okay, so stealthy. It's stealthy because it's harder to detect, lower network footprint. The reason it's stealthy actually is because, especially if you use jitters support. Like jitter support means randomized callback timing to avoid pattern detection. Okay, let's say now you want to let's say that if for example that someone tried to do something on your network, okay, and you are like checking the network, you're checking the network traffic. Okay, you're going to notice that every 60 seconds, okay, there is traffic going on. This traffic is there is a communication going on. Okay, you're going to see this is something weird, right? Because every 60 seconds the same traffic goes. You don't recognize this traffic. You're going to be able to detect it, right? Because this pattern is going to be able to see this pattern, okay, to recognize this pattern. But if you randomize the timing, like you can say like now it's going to call back for 60 seconds, every 60 seconds, then the next callback is going to be after a different time. Okay, maybe 20, maybe 100 or something. It's different, right? So this is what we call by jitter. It's a way to randomize the callback timing to avoid pattern detection. So when to use? Beacons are used for long-term persistent access. Stealth operation, avoiding detection, production, real-world engagement when maintaining low profile is critical. Environments with aggressive monitoring. And network pattern, we have here implant, server, check-in at T1, receive tasks, check-in at T60, send tasks. So this is the idea. The implants will send to the server, check-in at T0, and the implant and the server is going to receive the task. And the server is going to send the task to the implant, then wait 60 seconds. The server is going to receive the task after 60 seconds, sends the results, the implement. Jitters, base interval is 60 seconds. If you put the jitter 30% or plus 18 seconds, actual callback will be random between 42 to 78 seconds. Breaks timing pattern, evades IDS and IPS signatures. Yeah, that's the benefit of this. And we have something called communication protocols. We have mutual TLS, which is this one. How it works is that both client and server authenticate using certificate. Okay, so encrypted channel using TLS13 certificate pin to prevent man-in-the-middle attack. Okay, that's TLS, mutual TLS. So both the client and server authenticate using the certificate. I think, yeah. Strongest encryption, modern TLS with perfect forward secrecy and mutual authentication. Server verifies implant, implant verifies server. Okay, actually this is what the mutual stands for, mutual TLS, because on both ends, whether it's the client or the server, they authenticate using a certificate. And it's harder to intercept. And the disadvantage is suspicious traffic. TLS to unusual ports may trigger alerts. Okay, and blocked by strict firewall. Yeah, TLS to unusual port may trigger alerts, and blocked by strict non-standard ports are often blocked. Use case: internal networks, trusted environment when security is greater than stealth. So that's the concept of MTLS. And HTTPS, I think everyone knows this, how it is, but implants communicates via standard HTTPS request. Okay, blends with normal web traffic, can use legitimate looking URLs and headers. Advantage: blends in, looks like a normal web browser, firewall friendly, port 8043, rarely blocked. Okay, because 80 and 443 are actually web protocols, right? We enable it in the firewall to allow traffic. This is never blocked by firewall, so this is a good option. Actually works through corporate proxies. Okay, so disadvantage: HTTP inspection, deep packet inspection can detect anomalies. This modern firewalls actually do deep packet inspections, so this can be detected. And TLS description: corporate SSL inspection can see traffic. Restrictive network when blending with web traffic is a priority. So the second is DNS C2. This is a commands data encoded in DNS queries. This is a protocol that's used to translate the IP to domain name. Translation, resolution. So commands and data encoded in DNS. Response contained encoded commands uses subdomains for data exfiltration. Data exfiltration is just taking data outside from the network. That's the idea of exfiltration. Let's say you hacked an system, an internal network, and you want to take some data out to you, like this exfiltration. This is the NSC2. Like queries this one and response to XT with encoded command. This is extremely stealthy. DNS rarely is blocked and monitored deeply, and DNS allowed almost everywhere. Firewall bypass. Okay, it has long reach, works in heavily restricted network. Disadvantage is very slow. DNS has a size limit, high latency, requires DNS infrastructure, needs authoritative DNS server. Extremely restrictive environment when all other protocols are blocked. So this is slow, and this is risky. And so WireGuard is a modern VPN protocol. It creates encrypted tunnels, fast, lightweight, difficult to detect. Performance: faster than traditional VPN, stealthy, designed to be undetectable, routes all traffic, not just to C2, and high performance operation, pivoting on VPN. So basically these are the protocols that we are going to use, but mostly we're going to use these two, HTTPS and mutual TLS protocols. Okay, and on the lab session we're going to use these two. And implant generation and format. We have here the executable format. This is actually a format for Linux. This is like exe for Linux. Native Linux executable, can run on any Linux distribution, requires execution permission. And exe actually for Windows, standard executable detected for by most antivirus, requires certification. Mac OS is for Mac OS. This is implant generation or formats. Yeah, you can, when you generate or make any implant or payload in Sliver, you are going to have to specify the formats. Like you need to mention whether you need it in ALF or EXE format. So library format, shared library, loaded GLS, persistent via okay. Shell code is raw shell code, position independent code. Okay, no PE ELF headers, can be injected into memory, used for in-memory execution. So this is the benefit of shell code. You can use it for in-memory execution. Use case, you can use it for process injection, reflective loading, and fileless attack. Okay, library formats, shared libraries like DLL, loaded by other process for DLL detection. Okay, service binaries, we have Windows service and can run as system. Starts automatically, requires installation. Persistence, privilege, escalation. This is what it's used for. Okay, and again, stagers are small initial payload. Yeah, remember we discussed this in the Metasploit session. I think we have two types: stagers and stage. Stagers are the initial footprint that downloads and full implant. Downloads full implant, reduces the initial footprint. Stager small, stage 1. Then stage 2, it will download full implant loaded in memory. Okay, size constrained delivery, example, evading signature detection. This is why it's used, because size constraint. Maybe there is a limit for the size, so initially you can just deliver a small piece, and after that you can download full implant. So listeners, we have listeners are network services that wait for implant callbacks. Okay, multiple listeners can run simultaneously, providing redundancy and protocol diversity. Okay, just network services that are waiting for implant callback. That's it. It uses these protocols that we discussed on the up, like MTLS listener, which you can put any ports here, 888 or 443. That's up to you. It uses the TLS 1.3 for mutual. HTTP listeners, you can use port 80 and 443 and encoded data. DNS 5.3 and WireGuard is configurable. So we can use all implants can be configured with multiple callback addresses. Okay, try MTLS on port 88, fallback to HTTPS on this, final fallback to DNS. Benefit: redundancy. If one protocol is blocked and other works, implant chooses best available protocol. Resilience: harder to completely block C2. Okay. This is actually a good strategy that it's used. Like you don't need to just set up one listener, one protocol, one listener. You can set up different protocols, okay, different listeners, okay, for a single implant. So you can do that for redundancy. Like if one is blocked, it can listen, the other protocol can listen to. So this is actually important. An armory system. What's armory? Armory is a Sliver extension system that integrates third-party post-exploitation tools, allowing operators to leverage existing offensive tooling without leaving Sliver console. Sliver extension system integrates third-party tools, post-exploitation tools, allowing operators to leverage existing offensive tooling without leaving the Sliver console. Yeah, this is what I said. Armory is actually, the benefit of Armory is, if you remember, we discussed in the Metasploit or the Active Directory, the tools that we use for privilege escalation and lateral movement and credential dumping, like Mimikatz, PSExec, and Sharp, Bloodhound, all these tools, like we had to install it separately, right? We have to go through we have to open a terminal and do it on a separate terminal, right? But Armory, it's a way that lets us to do it in the same Sliver terminal. We don't have to go to another terminal to perform this, or we don't have to do it separately. We can do it on the same Sliver terminal. How it works, it uses beacon object files, position independent code snippet, extensions, precompiled tools package for Sliver, assemblies, .NET execute. So installation process is that operator installs extensions from Armory. So you're going to install it. You install the tools by using Armory command. Sliver downloads and catches the tool. Tool becomes available as Sliver command. It's going to be part of Sliver command automatically when executed. Tool runs as a target and returns an output. So let me tell you the example here. For credential access, we can use Mimikatz, right? Instead of downloading or installing Mimikatz separately, you can just install it part of the Armory inside part of Sliver command, and you can use it to extract password, hashes, ticket from memory. Okay, Rubius, this is a tool that performs Kerberos attacks, like for ticket manipulation and roasting. Okay, Puppycats, Python implementation of offline credential parsing. Procdump dumps lsas.exe for offline analysis. And we have other tools like privilege escalation. Sharp Up enumerates privilege escalation vectors. This tool is actually used for enumeration. You know, we talked about it in privilege escalation. There is one tool, WinPiece. We talked about WinPiece, but Sharp Up is also another tool that does the same thing. Basically, just checks for misconfiguration or any privilege escalation vectors. Okay, Watson just checks for missing paths and exploits seatbelt, comprehensive host enumeration. And lateral movement, we have multi-protocol lateral movement tool like Sharp Map Exec, Sharp RDP based lateral movement, Sharp WMI command execution. Also, we can use PSExec actually for lateral movement. All these commands can help us to move from one to Active Directory. You can use Sharphound, Bloodhound data collector. Yeah, so Sharphound is actually just an executable file, executable tool that we install on the victim's machine. We run it and to collect data for Bloodhound. Okay, Sharp View, like Power View port for C, AD search, LDAP querying. Sharp Persist, window persistent tool. This for persistence. Okay, what are BOFs? Beacon of object files. So BOFs is a small position independent code, executes in process, no new process spawned, minimal memory footprint, originally from Cobalt Strike, compatible with Sliver. Benefit, it's OPSEC safe, no process creation, less dependent detection. So that's the idea of this one actually. It doesn't create a process. Okay, it's fast execution, runs in implant memory space, versatile, can perform almost any operation. Limitation, Windows only. Most BOFs targets Windows. Limited, not suitable for large operations. We have here it's just using a compromised system as bridge to access networks that are not directly reachable from the attacker's position. So this part is actually let's say you have like, yeah, this is a good example actually. Let's say you have an attacker. You're an attacker and you can reach DMZ, okay, but you can't reach the internal network. okay, or the sensitive subnet. But the DMZ can reach the internal network and the sensitive subnet. So you can use a method called DMZ, so that those you can use it to get access the internal network using the DMZ. Okay, without pivoting, you're going to be stuck in the DMZ, right? Cannot reach the internal target. But with pivoting, you can use DMZ host as proxy. You can just use it as a proxy and access internal network through compromised DMZ host. Okay, like we can use this SOCKS. It's a secure socket protocol for routing traffic through proxy server. Basic TCP proxy. Supports TCP and UDP. احس انه يعني ما نغري فاتوس. طيب اقول شو اسمه so SOC 4 basic TCP proxy support SOC 5 supports TCP UDP and authentication. So I think we're going to use SOC 5. So how Silver SOCs work? So basically SOC is just a protocol for routing network traffic through a proxy server. Okay, how Silver SOCs work? Silver starts SOC 5 server on attacker machine, like using this one, and traffic sent to this proxy is tunneled through implant, and implant makes connection from inside the target network. Response through the same channel. Traffic is sent to the proxy. Sent to this proxy is tunneled through implant. Implant makes connection from inside the target network. Responses return through the same channel. So this is attacker tool. This is the proxy, SOCKS proxy, and this is Silver server tunnel, implant, internal network. Using SOCKS with proxy chain tools, proxy chain, SOCKS proxy. So proxy chains configuration is SOCKS, this one. What can you do with SOCKS? You can do port scanning for internal network, okay, access internal web application, RDP to internal hosts, SMB for file access, database connections, essentially anything that supports SOCKS proxy. It's flexible, routes any tools through it. No need to configure specific port for network access. Slower due to tunneling overload. Not all tools support proxy. So port forwarding, again, this one, this you just need to understand the concept. Actually, we'll do it on the lab and we'll try to understand what we can. We'll do more on the lab. Is a way to split payload delivery into stage to reduce initial footprint and improve evasion. We have stage 0, tiny initial payload, often shell code and small executable, bypass size restriction, buffer overflow, payload size limit. Yeah, this is the initial payload dropper. And stage 1 is stager, downloads larger payload, may decrypt, obfuscate. Stage 2, minimal functionality. Stage 2 is full implant, complete C2 implant with all features, loaded in memory, fileless, full post-exploitation capability. So multi-stage deploy payloads is actually useful. Initial payload smaller, easier to deliver, fileless. Stage 2 never touches the disk. Only stage 1 scanned by AV, benign looking. Update stage 2 without recompromising. So this is it. So see, it starts with 100. It exploits actually 100 bytes. So it only does it by stage. Implant profile, pre-configure implant settings for reuse and consistency. Remember we talked about the communication protocols, this one, MTLS, HTTP, callback. So profiles are just a way to define the settings. Instead of setting, when you make a beacon, when you create a beacon or a session implant, when you generate an implant, you'll have to define the settings, right? Manually, you'll have to define the jitters, the callback intervals, target OS, architecture, output, all shell obfuscation settings, all this stuff, communication protocol. But let's say, but if you want, you can pre-configure the settings like a template, basically. When we do a template, just so that later on you just mention the template and it will automatically be set, right? So it's just, you can configure this one. You can use it. You can use the profile. You can create many different profile, different setting configurations. Okay, then you just mention the name of the profile and use it. Standard configuration across proven. Don't reconfigure each time. Faster implant generation. Track profile. Yeah. So basically, multiplayer team operations. It has an option of also multiplayer operations architecture. Silver server and how it works, server administration, features, shared sessions, multiple operator control, communication, login. All actions are actually logged. Multiple operators control same implant. Real-time collaboration, built-in chat between operators, coordinate activities. All actions logged with operator attribution. Audit trails for assessment. We have access control. Operators can have different permission levels, limit sensitivity. Large red team, including training, coordinating. So this is the idea of multiplayer team operations. Like you can have different teams managing the same implant, or multiple control the same implant, same payload. Okay, and yeah, reaction script, automate initial action with new session or beacon. Alerting, automatically run this one. Gather baseline information immediately. Execute script with high value target. Auto persistence, automatically establish persistence on certain target. So this is the reaction script. Automate initial actions when new session or beacon connects. Yeah, this is a good way to automate. Yeah, it will automate. There is a way to do it, like to run these 3 commands in one. You can script, right? And persistence, and define reactions, set the command or script. So you can just define the reaction and set the command or script, and assign trigger like new session or specific host name or user. When the trigger fires, command executes automatically. Okay, speed, immediate action without operator intervention. This is the benefit. Consistency, same command runs every time. Parallel elimination on multiple hosts. Traffic manipulation or evasion. Domain fronting, use CDN to hide through C2 server. Yeah, many CDN now blocks this technique. Traffic manipulation and evasion. Domain fronting is using CDN to hide through C2 server. HTTPS to CDN. CDN forwards to C2. You put CDN in the middle. Appears as legitimate CDN traffic. Okay, this is domain fronting. How it works: implant. This is the CDN, and this goes to the C2 server. So I match CDN, bypasses firewall and most header routes to actual C2. Many CDNs now block these techniques. Okay, fast flags, we have rapidly changing DNS records. C2 domain resolves to different IPs, harder to block via IP blacklist. Peer-to-peer C2 implant communicates with each other, no single C2 server to block. Implants communicate with each other, no single C2 to block. More resilient network. Peer-to-peer resolved to different IPs, harder to detect. Traffic obfuscation encrypts payloads, technology. So OPSEC in red teaming, operation security practice to minimize and trace, avoid detection during offensive operation. Avoiding detection, stay unnoticed by blue team's defender. You can delay responses if detected, slow incident response. Protect TTP, يعني don't reveal techniques to defender. Mission success, achieve objectives without interruption. Minimize footprint, use in-memory execution like fileless. Avoid writing to disk when possible. Delete artifacts after use. Blend in with normal activities. Operate during business hour. Use legitimate tools like LOL bins. Mimic normal behaviors. Limit exposure like short connection times, long beacon intervals. Encrypt all traffic. Means like you can increase this intervals. The longer they are, the less suspicious they are. Compartmentalize different implants for different phases. Isolate mission critical access. Don't put all eggs in your present. Defense in depth. Multiple C2 channel, multiple persistent mechanism, and access path. Common OPSEC mistakes are process creation. First mistake is that you are spawning cmd.exe, PowerShell.exe for every command. Okay, detection process creation event ID 4688. Use in process execution or BOFS, or migrate to a long running process. Okay, this is better. And network pattern mistake is that regular beacon callback at exact intervals. Okay, detection network monitoring beaconing detection. Use jitter, vary interval, random delays. Okay, privilege escalation using known exploits that trigger EDR. Okay, detection, exploit signature behavior analysis. Use LOL bass, token manipulation, less noisy techniques. Okay, lateral movement mistake PS exec to every host, creates services very noisy. Detection, events, logs, service creation. So it's better to use WMI for lateral movement. DCOM, or if it's available, or stealthier methods. Okay, credential access, we have running Mimikatz from disk. This is a mistake actually. Detection, AV, signature, file rise, and process. You can use in-memory execution, reflective DLL. Clearing, logging. The mistake is that some people will clear all the logs. Okay, but if they clear all the logs, then there will be an event 1102 log cleared obvious trap. So you just select selective log editing, or delete clean. Don't clean logs, blend in. Okay, then we have OPSEC techniques like fileless execution, load payload in memory, no disk writes, reflective DNN, DLL injection, PowerShell in memory, process hallowing, and token manipulation, steal token from other processes, impersonate with credential theft, less noisy than credential dumping, use built-in Windows Linux tool, signed binaries, less suspicious with custom tools. Timing attack, operate during high traffic period, blend with normal activities, long story. HTTP C2 protocol blending, looks like web browsing. DNS C2 blends with DNS queries, use legitimate protocol. Parent process, make malicious process appear to be spawned by legitimate parents. Make cmd.exe appear spawned by explorer.exe instead of implant. AMSI bypass, anti-malware scan. So detection methods, what to avoid. We have EDR, behavioral analysis, anomalies, anomaly detection, AD, signature based detection, application, and network detection, and we have analyze packets, log analysis. So basically this is what we need to know. Basic encrypt C2 traffic, use non-default ports, basic obfuscation. This is the basic way to do it. The intermediate beacon mode with jitters, in-memory execution, living off the land, selective logging. Advanced malleable C2 profile, multi-protocol redundancy, and parent process spoofing, token manipulation, no custom tools on disk. Expert domain fronting or CDN proxifying. This is actually ingesting custom protocol mimicry, and peer-to-peer C2, anti-forensic, and zero. So the idea of this is just we just finished the theory. We've talked about a lot of topics, more than the Sliver actually, but the reason we did like this is that on the next session we're going to go to Sliver, and it's a very advanced tool, open source tool. So we want to make sure that at least we understand the concepts of most of this stuff. Hello everyone, today we're going to talk about Sliver C2. Okay, we're going to try to cover as much as possible. We're going to do it practically. Okay, so I'm not going to talk about the theory. The theory we already talked about in the previous session. This is just a lab session. Yeah. So Sliver C2 is just we said that it's just a tool used for post-exploitation after you get initial access, Metasploit access. So first I'm going to try to use Metasploit to get access, and myself also. In order to transfer, but let's just start with the Sliver C2. Okay, to install it there are you can install it from GitHub, or you can just go to Kali Linux here, install Sliver C2, and you can just use this command, sudo apt install Sliver. It will install it automatically for you. Okay, and you can check the client here, and this is the server which we are going to use mostly. So the way to install is just like this: sudo apt install Sliver. Okay, then to run it you just type Sliver -server. It's going to run for the Sliver, not Silver, Sliver. So this is Sliver. Okay, initially it's recommended to update when you first start. You should update it actually. Just type this command update. It's going to update for you. Okay, mine is already updated, so I don't need to do this. And the next command, let's say we want to check the version, we can use this one, version. It's going to give us the version of Sliver. Let me clear this. Clear. And next I'm going to generate operator config. You can skip this part, but this is useful for if you are if you're doing this professionally. New operator, name, Kali, any name you can put. I'm just going to put as it is mentioned here. Operator, lhost. My local IP is actually I'll put lhost here, lhost 10.0.0.1, and generating client certificate. Okay, this is the first step we can do. Okay, then after this let's say we want to check if there are any listeners. We can use jobs. Yeah, we've talked about listeners in the previous video. Jobs are just listeners that you set up using the protocols, MTLS, HTTP, or DNS, or any other protocol. Okay, that it will receive the callback on this listeners. from the payload. So we need to start. There is one tool that you need to understand. Help will give us all the list of commands we can use. Okay, clear is just going to clear the screen, and this is just a basic command. We don't need to, and the armory, background, sessions, beacons, all this stuff. Okay, let me just clear this one. And let's say I want to create a session. Okay, we said that we create sessions are noisy, but for initially we need to create a session, right? And then kill the session once we created the payload, a beacon. Okay, because sessions, real-time persistent connection, immediate command execution, and this is the benefit of session. Initially that's what we need, right? But later on we can use beacons because callbacks at intervals and set intervals. So let's start with session. Okay, and there is one command you need to know, like --help. Let's say I don't know what to type after generate. You can just use --help and get help here. Okay, so generate is a command that we need to use to create either session or beacon. Okay, but now my goal is to create a session. So first thing I need to specify actually whether I want to create a session or I want to create a beacon. Okay, because I can create either with this command. Okay, so let me just create here, clear here. No, generate beacon. Okay, and I'm going, no, I mean session. I think for to create session you just need, you don't mention beacon and it's going to be created. Okay, and then I'm going to mention the OS, okay, which is Windows, and I'm going to mention arc, which is 64, I believe, yeah, 64, Windows OS. There is dash here, and I'm going to mention, I have to mention also the protocol that I want to use, whether it's HTTP or HTTPS, and I have to mention the port as well, the local host and the port. Let me specify the lhost. The lhost has to be mentioned as well. Arc here, string, CPU, AMD 64 actually. I think we're supposed to mention here Arc AMD 64, and the format, we have to mention the format as well, which is the whether it's XC or any other, so it has to be XC. And we have to mention the host, actually the lhost. I think it's -L, but let's, yeah, it's -L. In order to mention the IP, I can just use -L here, and we can type the IP here. This is my local IP, and I can type here 80 if I want to, but I don't think we have to do that actually in here, but we can type this one. There are more features. Let's see what it means. So this is generate here, we mentioned, and they used MTLS. Okay, and this is the IP, and this is the OS mentioned, and this is the architecture, and this is the format, and where you want to save actually. Yeah, you can just put here, and you can mention here where you want to save. -S, it's actually this -S, which is this -S, and and I'm just going to put it in the home. And if you want to name it a specific name, you can just mention session lab dot exe. Give it a name like this. Okay, before we move on, I think we can just change this one. Okay, let's use MTLS. You can use HTTP as well, but I prefer MTLS for now, and we can just make it 8080, our own IP. And let's confirm our IP exactly what it is. ifconfig config ifconfig here, and this is it basically. OS, where is OS actually? Why is it not mentioned? Yeah, so this is basically the commands that we use to create. And if you want, let's say you want to add evasion obfuscation, you can enable evasion features here. Override user space hook. You can just type this, add this, that's it. Okay, so it will add evasion features to evade antivirus or something, make it difficult for them to catch it. And canary is used like to check, like you can put canary like to google.com. That means like it will check from it will try to ping Google something, just to make sure that it has access to the internet, so it can communicate with C2. If it doesn't have access, it's not going to communicate with C2. So that's basically the idea of canary. Arc, we talked about its architecture. Debug, this just enable debug and output features. Disable signature, second is disabling Shigati Ganai shell encoder. This is an encoder that allows your payload to evade antivirus, or makes it hard for antivirus to catch it. Actually, it's not that much effective anymore, so it's not that much important. This external builder format, we talked about it, like extension. It can be any extension like shellcode or service or exe or shared, whatever. Help, just help. HTTP is a connection string. Key exchange, limit date time, limit execution to before date time. Like you want to execute this payload only after specific date, you can use this command. You want to limit execution to domain joined machines. Okay, you can use this command. Only the PCs that are joined to a domain. File exists, limit execution to a host with this file in their file system. Host name, local username, and max error, max number of connection error. Here you can specify it, and and more. We can add skip symbols. This will skip obfuscation. It will not hide your will not obfuscate your payload. I think this actually reduces the size of the payload, and but it makes it more likely that your antivirus will detect your payload. And yeah, I think that's about it for sessions. For beacons, there is more, but we'll talk about it later. Invalid usage of generate command and unconsumed input. Actually, it's not /l, it is /l. It is unconsumed. Try the I think the issue is the L part. Okay, and everything else, and this one also, it's saying something else. I think there's a mistake on our command. Yeah, so let's do it again, no problem. Generate mtls 10.0.0.2.800.880, and actually mtls has to be, yeah, Just remember not to forget that there is 2 dash between every option. Okay, so we can put here OS Windows because we want this to be /F. We can just mention exe, and -S we can just mention home slash session lab.exe, and architecture also is important, and don't forget to add dash here, and even in the S just add dash here, and architecture arc is going to be 64, and that's about it actually for now. Invalid -F, the format is not showing correctly. Yeah, because I'm using it as a. If I will use it, if I will use this just the letter F, I think we're supposed to put this way. Yeah, just S also. Yeah, so it's doing it now. So generating new command implant binary symbol obfuscation is enabled. So it's generating the payload, the session payload. Okay. So now that we have generated the session, I think we should focus on starting the listeners. Okay, so our session will be here. Okay, you can just copy this and cd. Actually, it's here itself. ls -l -l, and you just grab session lab. Yeah, this is the one actually. Okay, so there are different ways to transfer to the victim machine, but I prefer to use the Python 3-m http server.8000, and we can go there and check it, and try it here, and actually now if you run it, it's not going to work because still we didn't set up the listener, but I just want to type this one and mention 880 and the name, which is beacons lab, I think session lab, right? Let me just put the name here. No, it's actually just session lab.exe. Me. Yeah, right now it's not going to work. In order for it to work, we have to add a listener. To add a listener, we just have to go mtls here and type L, and I think it's L actually, capital, and you're supposed to type the attacker machine IP, your localhost IP here, and this L is going to be the port, which is going to be 8080, right? We mentioned here the port, and I think that's about it. So if you go to jobs now, you're going to find it here. Okay, and this is how it's done. Okay, and again, you can actually set more than one listeners at the same time. You can set different jobs here, and this is good for redundancy, and in case if it's blocked and one port is blocked, the other one you can use the other one. So yeah, that's about it. Let's go ahead and run it and see what happens. Run this one, run, and see what happens now. Yeah, we got a message here. session, this one, and Vagrant. Okay, so now let's go ahead and type sessions here. This is a command to list all the active sessions we have. So when I type sessions, I was able to access this one, get this session ID. Okay, and you can just, if you have the session ID, you can just type the session ID here, and go to this session, social threads. Okay, now we are in the session. So let's try to go help here again and see what we have. So now we have access. We can try all these commands. Actually, we can try this this command related to Sliver window here. Okay, we can try get system, get privilege, impersonate, make token, ps exec, all this stuff. We can do it ourselves. Also, we can use these commands to navigate around, terminate, or whatever. Okay, so I think the next step should be, yeah, I just used the listener here, the port. Yeah, you can do also using HTTP. Okay, but for HTTP, I think we use the, yeah, that's about it. Okay, so multiple listeners for redundancy you can set up. Implant will try all protocols to call back. This is one thing. Delivering and executing impact, we did this already. And direct connection, if you have a shell, yeah. So check for callbacks, use one, use tag. This is done. Information gathering, yeah, these things we need to try. Okay, now that we got access to the PC, okay, so we can try info here. It's going to give you the session ID, the name, UID, username, UID, and so on. We have who am I here, who am I. Okay, so we have get UID command. This is going to give you the UID, get PID. This is the PID, process ID of the implant. PS, this will list all the processes available. IF config, this will give you IF config, will give you the IP of the victim's machine. Let's start network connection on the network connection. Let's see where we can find our session here. 8082 established. And we can do other things like file system operation, like PWD here, just to see where we are right now in desktop. And we can type ls to see what we have in the desktop. And we can type cd -etc. This is actually for Linux, but it seems it's working. So ls you can use cat etc.password. This has to be from Linux because yeah, for Linux you can make directory here, make dir, and do whatever you want to do. And you can execute commands here. Actually, execute commands like execute username, Okay, this shouldn't work again. This is for Linux. Shell will work. It's going to take you. The action is bad for OPSEC. Are you an adult? Yes. Wait approximately 10 seconds after exit. Okay. Now I have shell access. Just go back. We don't need to do that actually. And we have execute OID. So yeah. Now the next step is actually to check with beacons. Try with beacons. This is basically how it works. Okay, when you type any command, you get a reply immediately. You got me? So when you type, but when you try this stuff, all these commands, the same commands on beacon, using the beacon, it's not going to display for you immediately like this. It's going to take time. Yeah, it's going to wait for a callback based on how the interval you set it at. Okay, so let's just this. Okay, so let's just do jobs here. Okay, and clear this one. Okay, we're going to do beacons now. We did sessions already. We're going to do beacons and type this one. Okay, I'm just going to mention save on the new beacon, beacon.exe, beacon.exe. Make this one .exe. Jitters 30 seconds, leave it at 60. This is AMD 64, and this one leave it at Windows, and okay, leave it 888. That's fine, and just put this one there. Put this 0, 10, and MTLS. Yeah. So this is fine. So now that we created the beacon, I think we should set up a listener as well. We should set up a listener for the beacon, for this beacon, and we can just set up this listener. Type this command here, and yeah. So now let's go ahead and run this one. New beacon.exe, new here, beacon.exe. Run this one, run, and once this is run, just type beacons here. Beacons. Yeah. So this is it. So we just successfully created a beacon here, and we can just copy this one, the beacon ID, and we can use it here. Type use. In order to use the beacon is the same. You just type use and you just type paste here, and we're inside. So let's say we type ps. You see, it's not going to execute the command right away. pwd, whatever you type here is going to be in the queue. To check the queue, you just type tasks here. Okay, you can see what's pending and what's completed. So you can type here tasks again. Yeah. So it will only be execute the commands when we got a callback. You see, we got the output here for PS just now. Because it only executes the command when it receives a callback from the implant. Okay, so that's the difference between beacon and session. You have to wait so much time in beacon sessions, you'll get it immediately, and this is actually stealthier also. So when we created the beacon, we added jitter here, so to confuse the the SOC team, if the company that you're trying to penetrate, they have a SOC analyst team, they're going to see a pattern. Okay, if you try to send, if your call back every 60 seconds, which is but if you use jitter, it's going to randomize timing to avoid pattern detection. And it will sometimes have more or less, the time. It's going to change the time it sends it. So if it sends it first time, it's 60 seconds, it sends the call back. At the second time, it might be 100 or more or something else. It's different. So now that we did this, and we have we want to try all the other commands. We just tried this one also on the same commands you can use on beacons as well. And the thing is, with beacons you have to and the same commands you can use. It's going to be tasked, and you can adjust beacon timing. You can reconfig here. You can just reconfig the seconds to 30 seconds, jitter to 20. You can change the configuration here. I think it's because we're not supposed to use the let's just type reconfig here and see help. Let's see what's the commands that we can use, and I think you can use -t. There is no such thing as seconds in commands here. -t, then help here, and or -timeout. -t is not working, so timeout. Timeout here, and beacon interval is beacon callback interval -i. طيب, yeah, and there is one more command, interactive here. Interactive, this converts to session-like behavior. Now commands execute immediately until you exit interactive mode. Okay, and you can use this command to make it behave like a session. Now if we type ps, ps, it's supposed to behave like we're using beacon C2 endpoint and task beacon. Okay, because the reason it's not working is because still it didn't run the tasks. Just give it time. It's going to run it's going to make it interactive. So now let's try to do it actually. pwd, again it's not affecting, but this interactive is supposed to work actually, even though the task is completed. But it converts it to session-like behavior. Okay, let me just put background here. Background. Okay, and the task management, we said task here. If you want to cancel a specific task, you just type use cancel and type the task ID. This is the task ID here. And clear task, you just clear all the tasks. And we have armory. We discussed this in the previous. So armory, we've talked about armory. We said these are a way to install third-party tools like Mimikatz, Rubius, Sharphound, Seatbelt, and SharpUp, and lets us use this tool inside Sliver instead of going to another terminal or opening another terminal and installing another tool. You can just use it inside Sliver. This is the command armory install all. We just install this one. Armory install all. It's going to install all for me. There are actually 22 lists. and it's going to download for us all the tools. Sharp Hound, Sharp WMI, Sharp Drapi, Sharp RDP, and Sharp SMB Exec, Sharp SH, Sharp Up, Sharp Sec Dump, and Sharp Labs, Sharp SQL Recon, I'm going to pause the video because this is going to take a while. Okay, now that we have already installed the Armory tools, okay, now it's time to try it out. We're going to try the key tools only. Sliver server. Okay, there must be an issue here. Load 22 aliases from disk, subroutine running. Alright, let me no, I think it's help. Okay, it finished installing. So now we are actually supposed to try each command. Yeah, we're going to try the key commands, the key tools, very important tools. Yeah, I'm going to try the tools that are very useful. I already installed it, and as I said, to install any tool you just have to type AMD Armory and install and tool name. Okay, so I installed tool. First let's just let's check the sessions and use this one. Actually, we need impressive poisoning. I need, because it's the latest one. Like, and let's use seatbelt group equals to all. Invalid flag help. So I just use seatbelt. These are the flags that we can use with seatbelt. Seatbelt is just it's used to complete host enumeration, shows everything about the target system. So it's a complete, it reveals privilege escalation paths, credentials, misconfiguration, installed software, or running services. So let's just bypass MSI on Windows. Only supported when used with in-process application domains, and so seatbelt command. So if I just run seatbelt command now, what happens? It's just going to execute seatbelt, and it's going to display nothing, the output, because I didn't mention anything. But So let's try seatbelt ARP table specific checks. I just want to see if it's going to work. Yeah, it's working. It's just showing us the ARP table. Login sessions. Seatbelt login sessions. It's just showing me the login sessions, all the users and their details, local users, and paste. It's showing me the local users detail, all the local users we have here. And interesting files. We can type this one and see how it is. Interesting files. Jack of all trades, Jack of hearts documents. Yeah, so let's try sharp up. This is important for privilege escalation. Finds window privilege escalation vectors. Let's just use this command, sharp up audit, paste. Should output modifiable services, unquoted service path, always installed, scheduled tasks and stuff. Large number of false positives, so they just give us a potentially hijackable DLL here, and files in C program or C may have maybe false positives. Permission should be verified manually. Associated process in Kraken PID, potentially hijackable DLL we have here, and yeah, we can check this one. You can check if you find anything here. We can see if we have any unquoted service or something, which I think we have, because we created something like that with the before, I think. Yeah, we created something. If you find something, you can just create execute this one, okay, and execute the start service. So config one service and pin path, so it will run our implant. Basically that's what we can do. Let's see where we have vuln service here. This is actually a service that I created before for test. Let me just try to run it, start it, paste this one. Okay, this should start the service. So the path, it's going to be right, let me just run this audit again. You can also run this one, by the way. This command to find if it is unquoted or not. No, it's just. So where is vuln service here? Vuln service. Okay, we have Rubius. Let's try the other services. Rubius dumps current Kerberos tickets. You just try this one. Rubius dump. Just dumps for me the tickets for the Kerberos. Actually, it's for all. It just dumped for me the Kerberos tickets. Rubius Kerberos. This will do the Kerberosting. Kerberosting. I think this is because, but it is Kerberosting. Yeah. Service host, total Kerberostable users. We have 2, so we can check which users are Kerberostable, and we can take the hash here. We've talked about Active Directory before. As reply, we can do this also. Request TGT with the NLTM hash over the pass hash. We can use this command. Pass the ticket, harvest ticket.